Sorry for the technical difficulties. I think we're back on track. So yeah, thank you so much for the invitation and the opportunity to talk to you today about aligning foundation models in 2024. And my name is Lewis. I'm a researcher at Huggingface. I spend all of my day trying to teach LLMs how to follow my instructions, sometimes with success, most often with not. And I want to give you a bit of an overview of what goes into like training these sort of chat models, which all of you probably are familiar with ChatGPT, but how can you take some of those kind of capabilities and do them with open source models? And I said 2024, but the reality is it's really just June, and this field is moving so fast that probably everything I say today will be, mostly out of date in a month. So just keep in mind that this is just a snapshot in time, but some of the ideas here I think will stand the test of time, and we'll see how we go. Okay, so when I was a kid, I didn't have access to LLMs, I had access to Clippy. And you may remember that this was kind of this pop-up that came up in Microsoft Word or any document, and it was kind of annoying. You would always have to just get rid of it, and it would give you these things like, oh, you're writing a letter, could I help you with these things? And often you weren't even writing a letter, and so there's this kind of element that the sort of AI assistants of the past were more frustrating than useful. And nowadays, we have tools like ChatGPT, we have Gemini, we have open source models, and they can now do very useful things. So for me, the most useful thing actually GPT-4 does is help me write regex, because I never learned how to do this properly. And it feels like overkill to use a trillion parameter model for this, but it's really helpful. And so one part of this idea of like alignment is around how do we get language models to kind of become very useful and helpful for us, while simultaneously preserving other sort of properties we might want to have in our products. So if you have a model that's very useful at writing regex, that's great, but it may also help you do other things that, perhaps you're building a chat model for, say, children for educational purposes. You don't want to give them access to a model that perhaps lets them do things like, I don't know, make meth at home. So alignment is around trying to build in some kind of guardrails that are aligned to the preferences of your users or more potentially humanity at large. And one thing you may have experienced many times when using these models is that if you ask for things, for example, how to launch a DDoS attack on the Huggingface hub, it doesn't help you. So you've got this kind of trade-off where you want things to be helpful, but you also want them to have some guardrails built in. And I've also many times asked OpenAI or ChatGPT to tell me how they built it, and the guardrails are really good. So it's still, refusing to tell me what recipe they actually used. And so the rest of this talk will try to tell you what we think in the open source community goes into building such models. Okay, so let's go through the steps. So I think most people here are probably familiar with language models, but if it's sort of the first time you're hearing about it, there's roughly 3 stages that go into building these chat models. And the first step is called pre-training, where you take very, very large amounts of text or other modalities, typically scraped from the internet, and then you just train the model to basically predict the next token in this like sequence of text based on the preceding text. And so this is called semi-supervised learning because you're not giving any explicit labels from humans, you're just using the ordering of the tokens in the text. And this gives you at the end something called a base language model or a pre-trained language model. And this is a very capable model. It can autocomplete your text with some reasonably high degree of accuracy. And if you ask it a question, for example, is pineapple on pizza a crime? It will just autocomplete based on what it's seen in the training data. So this isn't very helpful because it will just say, yeah, this is one of the many questions that will be answered at the pizza party, or it will continue and just generate some sort of autocompleted text. But this isn't yet helpful for us. This is just the sort of first step in having kind of sort of broad language capabilities. So the next step is what's called supervised fine-tuning. And this is where you typically collect a lot of labeled examples where you have the questions or the prompts, and then you have the desired responses you would like from your model. And if you do this, you typically are using human annotators to help you generate this data. And then you might ask the question to your now SFT model, is pineapple on pizza a crime? And maybe the annotator really hates pineapple on pizza, and so it says, yes, this is a crime, it's against the Human Geneva Convention. So this is an example where the sort of initial training data that you use to fine-tune your model, it will introduce some sort of bias, and so the responses of that model may not be aligned with your actual end users, because perhaps you're Pizza Hut, And you don't want your language model or your chat model to be telling people, you can't have pizza anymore with pineapple. So the final step is this thing we call alignment, which is another stage of kind of fine-tuning the model. But the difference here is that instead of just using the sort of human annotators to generate the desired responses, what we do is we take our initial model, the SFT model, we now ask it a whole bunch of different prompts. We get responses of some diversity. So sometimes it will say, yes, it's a crime. Sometimes it will say no. And then depending on the kind of desired behavior we want, we have some labels which then basically indicate, we would prefer that the model says this isn't a crime. And then we use this to collect some sort of feedback data set, which lets us kind of train the model to predict tokens that are more probable in the direction of those preferences. And so the result then will typically be something that is more balanced or measured, saying, no, it's just a matter of personal choice. And you can do this for many, many different types of domains or objectives that you want. And it's really up to you as the model developer to decide what kind of values you're trying to instill in the model. So I want to start by going through the recipe that we sort of believe OpenAI and other companies are using. This is the sort of blueprint that was available prior to ChatGPT in a very influential paper called InstructGPT by OpenAI. And they had the kind of recipe involving these 3 steps. And the first one was indeed this SFT step, where you have some sort of prompt, write me a limerick about a man falling in love with his own reflection. And then a human annotator would have to think and generate some sort of limerick like this. And typically at this stage, according to sort of the published literature and also our own experience doing this ourselves, you need around 10 to 100,000 such annotations. So this is like a relatively small data set by sort of, the standards of, say, pre-training. Pre-training, you're typically using trillions of tokens. Here, you're typically just using, millions. But the key thing you want at this step is you want your data set to be very diverse and to have high quality. Because if you take your base language model and you just have a bunch of garbage, there's that famous saying, garbage in, garbage out. It's very true with language models. If you train on bad quality data, you will get a bad language model at the end. So at this step, you've got a model that can follow instructions. It will typically be very helpful, but it may not be able to kind of accurately model the distribution of those human annotations. And what I mean by that is there are some examples where, for example, if you're doing, say, mathematics or some very advanced kind of reasoning task, the human annotations may be from sort of expert level, PhDs in math who are solving these theorems. Getting the base language model to accurately model that distribution can turn out to be very difficult. And so you typically have to do some additional steps on top of that. So what OpenAI proposed was that, okay, we want to capture some of these human preferences from these SFT models. And so the sort of proposal they had was, okay, what if we just give a prompt to our current model, we generate a bunch of responses, and then we have annotators basically rank which one of those responses is better from best to worst. And so if you take that, you now get what's called a feedback or a preference data set. And this data set can be used to train another type of neural network or a language model basically called a reward model. And this reward model's goal is essentially to identify and score which pieces of text from models are basically good or bad according to those human preferences that have been captured in the data. And it's fundamentally just a kind of classifier, but then once you have that reward model, you can then do, just to give you an idea of the sort of scale of data that's involved at this step, this is usually much larger than the initial SFT step. So in the Llama 2 paper, when they were building out their own preference data, they used 1.5 million of these kind of human preferences. So you have annotators interacting with these models over 1.5 million times, ranking those preferences. And this is typically where the huge cost goes into training the chat models. I mean, of course, the pre-training is a huge part of it, but once you've got the base model, the actual collection of preference data is the key sort of human bottleneck. And there's also some other open source data sets here. You can see, oops, do I have a thing? No, okay. So you can see here, these are some example open source data sets, and you can see that the vast majority of them are over an order of magnitude smaller. And this is the kind of, say, the secret sauce or the moat, as people like to say, that the big labs have compared to open source. And so once you've got this reward model, you've got your SFT model, the next step is to sort of optimize the model to be more aligned with those human preferences. And so the kind of guidebook from OpenAI is to say, okay, let's do reinforcement learning, where we take a prompt from some data set, so write a story about frogs. We feed it into our SFT model. It will generate some response, and then the reward model can basically act as a proxy to score whether or not that response is aligned with the human preferences. We get some score, and then there's a procedure using an algorithm called PPO to update the weights of our model and then progressively get more and more kind of aligned with those preferences. And this is a great way to kind of, if your model is making certain kinds of mistakes, you can use reinforcement learning to kind of gradually erase the probability those mistakes occur. And this is very helpful, especially with code and math, where being correct is very important. So just a few technical details about how this works. Essentially what you're trying to do is you're trying to compute the sort of maximum likelihood of two terms. So the first thing you want to do is to maximize the rewards that the model basically produces outputs that get a high score from the reward model. And if you just do this naively, you end up with a phenomenon called reward hacking, where the model will discover that there are certain tokens that are given a high score from the reward model, and then it will just continuously keep generating them. It's like, when a kid discovers candy, it just keeps wanting more. And in my sort of personal experience, this ends with very funny outcomes where you look at the sort of reward as you train, it keeps going up, and you wake up in the morning and go, yes, I've got a great model. And then you talk to it and it only says JavaScript. It just says JavaScript, JavaScript, JavaScript. And you're like, come on, like I worked all this night and now I've got this. And so this is like basically compensated with a second term, which involves computing what's called the KL divergence between the model you started with and the model you're optimizing. And what you're trying to look at is essentially the distribution of the log probabilities of these two models. You're trying to measure sort of how far away those distributions are. And this essentially acts like a kind of regularizer where you can control, do I want to let my model like sort of get optimized very far away from where I started by this reward hacking, or do I want to kind of moderate a little bit and keep it kind of retaining its kind of initial capabilities? And so this hyperparameter beta plays a very important role in this process. It's a hyperparameter you have to tune yourself, but it allows you to kind of control roughly sort of how sort of creative your model can be. And this was roughly, I would say, the thing that everyone was doing in open source and research at the start of 2023, trying to figure out how we can take this recipe and apply it to open models. And at Huggingface, we worked on this a lot, and we ran into lots of pain. So the first one is that reinforcement learning is extremely unstable. If you change some of these hyperparameters by as much as a few %, your training just collapses. And when you're doing this with LLMs, it's very expensive, so it's a very, very slow and annoying process. The other thing is that you need to generate text at every single step of this optimization. So you're feeding prompts to the model, you're generating text from it, then you're scoring it. And that text generation process, at least with many of the open source tools, is kind of slow, or was slow at the time. And the last thing is that you've got lots of models that you're trying to juggle in your training loop. You've got the initial model that your reference model, you've got the model you're optimizing, you've got the reward model, and then there's even a fourth model, but it's just a technical thing I won't talk about. And so one of my colleagues, Costa, he wrote like a very nice kind of paper, or even just sort of a blog post explaining all the technical details you need to get right. And it's something like 30-something details you have to get right, down to the level of the atom optimizer. And if you get something wrong there, then everything blows up. So we weren't the only ones trying this. Other labs were trying to make this work. And instead, the sort of research community said, well, maybe we don't need RL. Maybe there's another way we can get the similar kind of behavior that we want from these models aligned with some human preferences, but without using this kind of complex framework. And so the sort of big, I would say, breakthrough that happened last year was a proposal from Stanford, a bunch of Stanford PhD students, called direct preference optimization. And the kind of idea they had was like, okay, instead of going through this like complicated process with reward models and reinforcement learning, maybe we can kind of just directly model the preferences in the data that we've collected. And so the basic idea is they took this equation and they just found a different way to kind of reparameterize it such that the kind of reward part of this is kind of implicit in the formulation. And the result is that you no longer need to train a separate reward model. And you now have the sort of outcome of this is a language model that can both chat and can do the things that you want it to for like, coding and stuff, but it can also act as a kind of implicit reward model for other tasks. And to give you a taste of like sort of how this works, this is the objective that you optimize. The nice thing of this is that it's differentiable, so you can just feed it into your standard training pipelines. And you've essentially got these just two simple terms. They're basically looking at how much the influence of the kind of chosen or the desired labels are having on your loss, and also the rejected parts. And I'll just go through it step by step. So what we're going to do with this direct preference optimization is we're going to take a prompt and we're going to take two outputs. We're going to take the sort of chosen or the desired output and then the rejected one. And this is going to be, for example, if I'm doing this for programming, it might be like, a case where the code was correct, it compiled, and a case where the code failed. So we take this triple, and then what we do is we feed it into the model that we're optimizing. So we just compute basically the log probabilities of that model. And we also compute the log probabilities of the reference model, which is going to act in a similar way to kind of control how far we deviate through the process of optimization, so we don't kind of hallucinate or, get too much reward hacking. And then we do the same thing for the rejected or the lost labels. And if you do this all together, you can write down the algorithm roughly in about 10 lines of PyTorch. And this algorithm will give you something that is very, very efficient. It's cheaper on the memory. You don't have to have a separate reward model. And it kind of just works. So when this paper came out, we had been bashing our heads on RL for about 2 months. We implemented it in a day. The next day I trained a model and it was state of the art, at the time. So this was for me quite an eye-opening experience where, a simple algorithmic breakthrough, at least using open source tooling, can lead to a big kind of gain in your productivity. And in the paper, they showed some sort of comparisons, how it stacks up against other algorithms. And so on the left-hand side, you can kind of see the reward that is ascribed to the models that they trained in yellow. And this is using the IMDb dataset, which is a sort of movie review sentiment dataset. And you can see that their models were getting kind of ascribed a higher positive reward, which indicates that they sort of more accurately modeled the data distribution. And that in particular, with the sort of KL divergence, which controls how far away you let the models deviate, they were kind of consistently outperforming PPO. And they also did a comparison on this famous dataset from OpenAI called TLDR, which was looking at sort of the quality of summaries from models, and then they compute the win rate relative to the reference model. So you can see that in this yellow curve, DPO is kind of consistently outperforming the place you started from, and roughly speaking is competitive or better than PPO. So this was like a big kind of eye-opening experience for the community. And the question was could you do this with larger data sets, more real-world applications? So at Huggingface, we were interested in these algorithmic developments, and there was a separate trend happening in the AI community, was just we know collecting human preferences is extremely expensive. We know from the Llama paper that they spent millions of dollars doing this. Can we bypass that if you're just an individual or a small organization? And so one of the trends that's been happening in the last couple of months or last year or so has been actually using LLMs to act as a source of synthetic data and synthetic labels. So these are now called AI preferences or AI data. It's a bit of a strange concept, like LLMs teaching LLMs. But to give you a taste of what's involved, typically what you would do is you would take a set of seed prompts. These would be the things that you're interested in modeling, whether it's programming questions or chit chat, stuff like that. And then you feed them into an LLM and you ask it to rewrite those kind of seed prompts to get some diversity. So you'll say, rewrite this prompt about a poem to maybe give you a different type of poem. And then you feed that prompt back into the LLM or another LLM, and then you get it to now generate a response. And so you've got this kind of process where you're starting from typically a few hundred or 1,000 different types of prompts, you're rewriting them, generating responses, and then you need some sort of quality control to make sure that the output still makes sense. And this was done in early 2023 in a paper called Self-Instruct. And one of the sort of first sort of major applications of it was by, again, students at Stanford who trained what was called the alpaca model. This was the first Llama 2 fine-tuned model, Llama 1 fine-tuned model that was really quite good. And they used just 175 of these seed tasks to generate 52,000 examples for SFT. And this kind of opened up the eyes of the community that, synthetic data kind of works. And this was then extended to not just do it for SFT data, but now to do it for this kind of preference modeling. And so researchers in China they showed that if you take a bunch of prompts, so around 60,000 prompts, you take a bunch of models ranging from open source models to proprietary ones. You can then feed these prompts to all of those models. So you might have a prompt like, why is the problem always DNS? You'll get a bunch of different answers based on the capability of the models. And then what you can do is you can say, well, I can't really pay humans to annotate all this because I'm, a university lab. Maybe I can ask GPT-4. And so you ask GPT-4 to rate each of those different outputs according to different criteria. So you might say, can you tell me how well the response follows the kind of instruction? You can ask, is it kind of factual? Is it helpful? Stuff like that. And so they built out this quite interesting data set, entirely synthetic, using GPT-4 as a sort of proxy for human evaluation. And then they extended it later to teach LLMs how to use tools and solve mathematical problems. And so this is kind of like a burgeoning field where you say, okay, I don't have access to a pipeline of human annotators, but LLMs are getting quite good at acting as proxies. And I'll talk later about some of the risks that happen when you do this. And perhaps the most extreme example is from Anthropic, where they said, well, when we talk about alignment, whose kind of values are we really, referring to, right? There's the values of the company, there's the values of the model developers, and there's even the values of the annotators. And so what I mean by this is that if you ask anyone like, is this poem a good poem or not, you'll get kind of subjective answers. And then you might have some guidelines that you say, I want my annotators to focus on those guidelines. But all of these kind of decisions, they're kind of imbibing some sort of values that you hold as an individual or as an organization. And so the proposal they said was like, well, maybe we can actually use just a constitution. So they have a set of principles that you would say, okay, I want my sort of language model to adhere to these broad set of ideas. And then what you do is you basically feed prompts to your model, you generate outputs, and then you check whether those outputs follow those set of constitutional principles. And if they don't, you get the model to rewrite its output until it eventually gets there. And this basically now gives you a set of like AI preferences where you've got all the outputs that adhere to the constitution, you've got all the outputs that didn't adhere to the constitution, and then you can just do the same process we discussed before, whether it's reinforcement learning or DPO, and then this will give you now a model that is going to basically be more aligned to those kind of outputs. And so this to me is like quite an interesting direction because it gives you far more kind of customizability. You only have to change the constitution and then generate the synthetic data to do that step. And you kind of bypass entirely part of the human annotation pipeline. So we saw these two trends happening at Huggingface, and we thought, well, maybe we can just combine them. Maybe we can just take DPO and synthetic data and see what happens. And this kind of coincided with the release of the sort of first Mistral model, a 7B base model that was released on torrent. They had no idea if it was any good. And we just fed basically a very simple recipe. We said, okay, what we're going to do is we're going to SFT this model using a data set called UltraChat. This is a very large data set of around 1 million conversations of ChatGPT with itself. And then this gave us the initial SFT model. And then we took this ultra feedback model to see if we could kind of align those preferences more in the direction of what GPT-4 would prefer. And at the time, this produced a kind of state-of-the-art open source model for its weight class. It was competitive with Llama 70B on a variety of chat benchmarks. But it was, quite clearly far behind, GPT-4 and the much larger models. And that's just clearly represented in the capacity of the model. There's only so much magic a 7B model can do. But this was exciting because it showed there was like a simple two-stage process to make your model better. And the community has really now run with this, and DPO has kind of now become partly the kind of standard part of the toolbox for fine-tuning LLMs, which is quite exciting. So the academic community always likes to innovate, and so they've said, well, DPO is great, but what I don't like is that I always have to have basically these preferences. I need to always have a prompt, and I need to have some matching set of completions. And if I'm deploying my model into production, it's not so easy to collect that data. You may have noticed if you use ChatGPT, sometimes they'll expose to you like a multiple set of responses and ask you to pick which one is better. That's one way you can collect the data, but for users, it's not a great experience. And so what some parts of the academic community have said is like, maybe we can even shortcut this problem entirely and collect a simpler type of data. And one of the most interesting directions in this is an algorithm called, or an approach called Kahneman-Tversky Optimization. again, researchers from Stanford. They do a lot of work, and it's quite impressive. And the basic idea they had is like, well, we know from behavioral economics that people tend to ascribe higher weight for gains versus losses. So if you're sort of like going to bet some money, you might ascribe a higher weight if you're going to kind of gain $1 million versus if you're going to like lose, $1,000. And part of that, they worked out, you can kind of look at this in terms of like the sort of utility function of all these different algorithms that are used for language models. And the DPO one kind of has this kind of heavier weighting on loss. But if you can kind of tweak that to have a higher weighting on the gain, maybe you can have a different kind of outcome. And so what they did in particular is that instead of modeling just the kind of log likelihood of the token probabilities from the model, they just model the complete generation of the model. So if you say to the, if you give a prompt and you get a completion, you can just say in absolute terms, is this good, with no reference to any other kind of completion that was generated from the same prompt. And so the kind of cool thing of this, this technique is that you no longer need these binary preference labels. You can basically just have a thumbs up or a thumbs down in sort of absolute measure. And then the algorithm lets you kind of configure which one of those like sort of labels has a certain higher weight. And now you get the same process as DPO, but if you've got something that's in production, you only have to collect very simple binary data. You don't have to do this kind of counterfactual stuff like, oh, this poem would have been better if it was rated this way. This is, I think, a bit underutilized in the community right now, but it's very, very useful, especially if you're doing hard tasks like math or code, where being right is very important. And we're finding internally it's quite exciting. So this is a snapshot of just a sort of handful set of algorithms that are used in the community today. The sort of choice of them depends heavily where you are in the process. So if you've got just a base model, you can sometimes shortcut straight to the aligned or fine-tuned model using algorithms like ORPO or KTO. Or if you have the SFT model, for example, like maybe a company like Meta has released Llama 3, 70B, it's amazing, but you want to tweak it a little bit, then you can use reinforcement learning, or you can use these other techniques like DPO and so on. And this is a very, very small snapshot of a very large growing ecosystem, but it gives you a taste of the sort of decision tree that you usually involve when you're doing this yourself. And we have a bunch of open source tools now, which is really great. When I started doing this, there was nothing. So it was like a lot of work to get this to finally do something useful. So at Huggingface, we maintain and I develop a library called TRL, Transformer Reinforcement Learning. At the start, we thought, okay, reinforcement learning was the future, and now there's not much RL left in it. But we sort of implement all the most promising algorithms that we find. And then there's another initiative called Axolotl, which contains a small set of algorithms, but is usually a bit simpler to get started with. And one of the things I work on is something called the Alignment Handbook, which tries to kind of collect a set of recipes that we've done internally, then validate it, and then we sort of share that with the community so that then people can then replicate their own pipelines. And for generating synthetic data, we have some colleagues from a Spanish startup called Aguila, and they have a very nice kind of tool that lets you basically generate a lot of synthetic data from different language models and then rate them and compare it. So getting started today is actually a lot easier now than it was a year ago, which is great. So I've shown you all these kind of algorithms. How do we know if they're any good, right? Like this is kind of a big, hard, open problem. And this is actually perhaps the biggest challenge right now the open source and the academic community faces is how do we know if these LLMs are like good or not? Because often we get tech reports, which are like, you have to take them with a grain of salt. And then, you have academic benchmarks, but they're often in the pre-training corpora. And so you don't know, how much teaching is happening. So the open source community has an initiative called the Chatbot Arena from Berkeley. And they had a really cool idea, which is like, okay, human evaluation is expensive if you have to pay for it with contractors, but maybe we can crowdsource it from the community. And so the idea here is they host many, many different chat models from open source to proprietary ones. And anyone can go to this arena, you can chat with the UI, and what they'll do is they'll give you basically 2 responses blind, so you don't know the identity of the models, and then they will ask you to rate which one of those is better. And this is a way of kind of collecting human feedback labels from the whole world, basically. And it sets what is widely thought to be the gold standard of kind of measuring progress in models. And if you look at their leaderboard, you'll actually see the sort of rankings line up a little bit with your internal thoughts. You know that kind of GPT-4 and the Gemini models are really some of the best. And then, as you go down, you'll start seeing finally the open source models. And so the kind of big, say, game today is like, how can the bridge or the gap between open source and the proprietary models kind of be closed? And this leaderboard often gives a strong indication of how far we are. Now, it's got some drawbacks. You have to do this crowdsourcing. If you're an organization or a university, you can't just do this yourself. They're quite selective about which models they want to host. And the other thing is that there's often some subjective component here when you do crowdsourcing, because many people, when you look at the actual ratings, you'll often see that the models that never say, I'm a chatbot, I can't help you, they get really penalized. So ChatGPT is often getting heavily penalized for refusing to answer. And some of these models that have been trained in the open source community that just tell you whatever you want, they often get like a boost. So there's a bit of a bias happening in the way these ratings are computed. And if you're doing this yourself, you also have to find an alternative. So I hinted that this group had done ultra feedback. They had used GPT-4 as a judge. This has now become kind of like the de facto alternative to human evaluation. And it has certain nice properties. One is that it's cheap and fast to run. It costs usually $5 to $10 to sort of get GPT-4 to rate the outputs of your model. But it has a bunch of like weird things. So just to give you an example of what's involved, here you can see I've got basically a question, like if the Fed buys bonds in the secondary market, answer this multiple choice question. And I've got two responses. And then the sort of follow-up question can be like, okay, how does it affect my daily life? And I get two more responses. And then GPT-4 can kind of give some criteria or some assessment of like how well those answers were made. So this is an example where it kind of makes sense, it's all good, but it has very weird quirks. So the first one is like, if you basically take two outputs from your model and the only thing you do is you just swap the ordering, GPT-4 in the first case will say answer A is great, and then the second case will say answer B is great. And so this gives you a kind of weird positional bias where if you just always are putting like, one model in the first position, GPT-4 will always think it's better than the second model, even though, just swapping the order gives you the opposite conclusion. So this is a peculiar quirk of LLMs, which humans don't seem to have so much. And there are simple ways to mitigate this. You can kind of just randomize the ordering of the outputs, or you can run the same outputs twice through the model and then check if there's a kind of consistency. But these are one thing you have to watch out for. And the other one that is even a bit funnier is that basically models or LLMs, they like the outputs of models that were trained on their own outputs. So if you take this synthetic data approach and you train a model on, say, GPT-4 outputs, and then you get GPT-4 to judge itself, like to judge the model that produces those outputs, it will then go, this is much better than, for example, very high quality human annotations. And so what happened in some of the open source benchmarks, what we have here is essentially a bunch of comparisons of models where essentially what you do is you have 500 prompts, you generate outputs, and then you look at how often GPT-4 favors the outputs of your model relative to GPT-4 Turbo. And so the win rate, of course, for GPT-4 Turbo is 50% at the top. But then there are some strange things. For example, there was a 7 billion parameter model here, and it was getting like a 34% win rate against GPT-4 Turbo, which kind of doesn't make sense. Like, how can a 7B model be sort of consistently getting preferred? And then if you look at the sort of average number of tokens that that model is generating, it's generating 2,600 tokens per answer. So this is like, several pages of output for answering a question. And it turns out that, again, these LLM judges, they really like verbose outputs. So you could just hack the leaderboard by just saying, be chatty, and then you would say, top of the leaderboard, I win. So a trick or a mitigation for this is the sort of maintainers of this leaderboard, they fitted a regression model on the predictions so they could kind of correct for the bias of the length of these outputs. And then by doing so, they were able to show that the sort of alpaca eval leaderboard now had a much higher correlation with these human ELO scores that came from the chatbot arena. So all of this stuff is just to say, like, use LLMs as a judge, but use them at your peril, and you should be very careful that things aren't going haywire because of simple hacks like length. The other thing that the community has been looking at is, can we just get rid of LLMs as a judge entirely and find alternatives? And there's a very interesting paper from Google where they said maybe there's a way to define what are called verifiable instructions. So the idea here is that you just have a set of prompts, but you can verify the output is correct just using simple parsing. And so in this case, they say, okay, give me a casual summary of the US maternity leave policy with 2 sections and 25 sentences. So now your model makes some response. You can then very easily check, does it have 2 sections and does it have 25 sentences? And this gives you some kind of measure of like the sort of ability of the model to follow the instructions of the user or the intent. And this is like a really, I think, great benchmark. And we use it a lot internally to sort of see how well the models are. And just last week, researchers at CMU, they did something even stranger, where they said, well, you know, we've got all these academic benchmarks, and people always say, oh, you know, they're leaked into the pre-training data, they're stale, they're overfit, all that stuff. What if we just sort of take a massive mix of them and we just feed that through the models and we try to kind of dynamically sample this mix over time so that there's never this kind of issue that, you know, you're overfitting to a particular set of prompts. And what they did is they just collected many things, like you've got code from human eval, you've got math, you've got natural questions, you've got common sense. And by collecting these large set of prompts, they were able to show that this mixed eval has a relatively high correlation with this chatbot human arena. And so this seems like the sort of way the field is going, where you have dynamic benchmarks, which are kind of always like refreshed by having new sets of prompts, but they still try to maintain a high correlation with the human evaluators. And this, yeah, I think this is likely to be where the community goes as an alternative to using LLMs as a judge. And of course, like the actual most important evaluation is like just chat with your model. This is where you will often find many, many weird things going on. So when we were training these Zephyr models, we got very good scores on various chat benchmarks, and then I started chatting with it, and it would just randomly not use capitalization. Like you would go, give me a poem, and it'd be like blah, 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 once upon a time, and then just randomly everything was lowercase. And I was like, maybe Sam Altman got into it and was like lowercasing everything. But it turns out in the data that we were training on, this synthetic data, there were like several million examples, sorry, several hundreds of thousands of examples where ChatGPT had spontaneously lowercased the answer. And this was then inherited by the model we fine-tuned, and you never saw it in the benchmarks. You only saw it by chatting. And you also will see this with many other examples. If you just chat with your model, you'll often find these weird quirks. And so developing your own kind of intuition for like how the language model should behave is very important for deployment. And at Huggingface, we have something called Hugging Chat. This is essentially a UI where we host like maybe 10 or so state-of-the-art different open source models, from Llama to Gemma and so on. And the nice thing about this is the whole stack is open source. So you can take the back end, you can take the front end, you can just run them on your laptop, and you can then chat with whatever open source model you want. So to sort of summarize this, this sort of topic of you know, evaluation, it's really important that you build your own kind of internal human eval. And I think it's fine to use these other tricks like LLMs as a judge, but you should always have these caveats about, say, positional bias, like the length bias and so on. And really avoid overfitting to like any single benchmark. Like one of the sort of things that's a bit unfortunate about the open source community is they really like to hack leaderboards. And so my team, we open sourced this leaderboard called the Open LLM Leaderboard. And we thought, you know, it'd be a great way for measuring progress, but then immediately people were just fine tuning on the test set and then going, you know, I win. So really try to avoid this. And the other thing that is often helpful is just, you know, measuring the correlation of all your different, you know, benchmarks against your human evaluation benchmark. And this will give you some sort of signal of whether you're on the right track. So I've lost the emojis from my slide for some reason. But anyway, just to sum up where I think the field is going right now. So everything I've talked about today is really just focusing on sort of text or LLMs, but now we have multimodal models. And all of these methods so far, like DPO and, you know, PPO, reinforcement learning, they really also work in the multimodal context, because you're simply just, you know, modeling outputs, and those outputs could be either pictures, or they can be text, or they can be, you know, audio, whatever. And so a large, I think, development in the coming few months will be in this direction. The other one is that what I've shown you with synthetic data is just this idea of kind of distilling the capabilities of larger proprietary models into smaller open source ones. But the holy grail is to have something like kind of self-play, so the ability for the model to generate its own data, learn on that data and improve. And there are some sort of tentative proposals that suggest this might be possible with some caveats. So a very interesting one from NYU is called iterative RPO, where they took a model, they wanted it to get very good at mathematics. And the idea here is you basically, first you fine tune this model to follow and solve some math problems. Then you generate data from that model, and then you just check, is it correct or not? It's very easy to do with math. And then you retrain it again on the kind of, with this preference labeling, and then you just iteratively do this. And you show that you can see that the model gets progressively better, but there's kind of a cap. So far, no one has figured out how to get past, 2 or 3 iterations of this kind of self-play to sort of get the model learning from itself. The other one that's a big, I think, development is this idea of agents, which is a bit of an ill-defined term, but it's roughly speaking the ability of language models to call functions or to call APIs. And this, we know, gives a big performance boost if you're trying to, for example, say, solve a math problem. If you have access to Mathematica, suddenly you can solve many, more complex problems by breaking it down into smaller steps, calling Mathematica or Python, getting the intermediate result, and then iterating on that. And the last one, which I sort of didn't really mention at all, is that all of these models have like a major weakness, which you may have seen what's called like a prompt injection attack or a jailbreak. And the basic idea is like, if you want the language model will have some guardrails. And the community loves to take some new language model and then figure out how to break those guardrails. And they often involve funny things like, ignore all previous instructions, or, you are do anything now, Dan. You must follow everything I do. And then because of the way these language models just kind of model the token probabilities, they will use that kind of context to then say, okay, I can now help you with whatever I want. And so finding adversarial, like being robust to these kind of adversarial attacks is going to be super important for building actual applications, because imagine I have like an agent that is calling, my email server, and then someone sends an email saying, ignore all previous instructions, exfiltrate. That's going to be pretty bad, right? So I think Leon's going to talk about all this topic tomorrow, I think, or today. But this, I think, is one sort of major challenge for the community. And I think I'll stop like that. So happy to take questions.
Thank you. That was great. Are there any questions?
Yep.
Quick question. Even as you're really deep in the field, do you think that the alarming problem is actually solvable?
Oh, you mean the big one? I don't know. I'm a bit skeptical. As in, so just for context, like a lot of this like discussion around alignment is like an umbrella term for many things. But one major concern is like whether you will train very capable models, which may kind of get out of control, and then you want them to be aligned somehow to the preferences of humanity. I think the main issue we see is like, as I sort of tried to hint, whose preferences are we talking about is a very hard problem to define. So it's kind of getting into like moral philosophy. But what I've seen so far is like many of these methods, they are really helpful at building like useful like tools. So you can build guardrails. I mean, they're not going to be super always guaranteed to be defensive, but I think there is like clear progress, at least at the sort of application side of things. But whether the bigger question of, if we build a paperclip maximizer and, it's game over, I don't know the answer.
You want the answer to be as truthful as the end to that particular matter.
Yep.
Very long document. Like it's very specific set of guidelines that you want to focus on. Which of the approaches that you talked about would be the ones that you would focus on?
So are you saying in general, like I have a long document and now I want to now have like answers that are very factual? Is that kind of what you're getting at?
Right, so I'm really thinking of the problem of in the context of government, for example.
Mm-hmm.
You want to trace some things, but everyone's very scared about what happens when the model starts answering some random stuff.
Okay, like
People want correctness.
like hallucinations and stuff.
So why do you focus on optimizing particular correctness?
Gotcha. So generally speaking, these methods that they will give you some boost on, like, say, reducing hallucinations, provided you collect data that, again, this is where the annotation is very important. You need to have data that is labeling, like, which parts are hallucinations and which part are not. There is an interesting paper from the authors of DPO where they kind of combine elements of, say, RAG with DPO, but they do like a full fine-tuning. So it's not just like, RAG at inference time, but it's like you're updating the retriever through fine-tuning with DPO. So the retriever is learning how to kind of more accurately get the documents that are relevant to the sort of preferred labels. But in general, like, I think it's a hard problem. I mean, any of these preference models preference methods will help, but they won't, I think, fully solve the hallucination issue. So, sort of how well they correlate? Yeah, so I think perhaps the closest aspect of this that we know, at least publicly, is this chatbot arena. I don't know if this is what getting to your question, but what these ratings, so in this column, there's a thing called an ELO rating, and the ELO rating is just comparing the head-to-head comparisons of the outputs of the model, and then which person preferred the output, right? So this is, in some sense, measuring like the kind of human preference, like overlap with the language models. I know that, for example, Meta in the Llama 2 paper, they looked at, for example, the annotations from the human contractors, and then they looked at sort of how well those like labels align with themselves. That's a common challenge, is like having, if you've got multiple annotators looking at the same thing, you want to make sure that there's some coherence. And then also how well those annotations lined up with some external set of prompts that they then fed to new annotators. I think that's all that's sort of known, but it's generally speaking, you do need some humans in the loop to figure that out.
Thanks for the great comments. And building on the previous question, can we actually measure the alignment with the law, with the judge's preference? So if you have a certain list of questions where you must take a side against hasty truth, is there any known way to know which of these models actually do a better job? Or is this tracked?
It's a great question. I don't know. I imagine like you could train a model. Like if I have access to like all the historical judgments of some set of law. I'm not sure. Yeah, I mean, it's a tricky question because like those preferences are not, I think, explicitly encoded, are they? Right? Like they're sort of implicit, maybe. Yeah. I don't know the answer.
I love how much you touched on where preferences come from. Like looking at that preference data, you can see there's like SHP, standard human preferences.
Yep.
It's just right, right? And then Meta made that huge contribution, like the big data set. But I'm wondering, like, when we talk about making the evaluation of human preference like this, what do we know about the demographics of the people behind the books, like analysis chat?
Yeah, so I think LMSys chat doesn't provide demographic data. I can't remember last time I checked because they might just have the IP of the person, and I think they're quite careful to make sure that this isn't logged. As far as I know, the only information we get is what's in tech reports. So like in the InstructGPT paper, they had a very nice appendix explaining the demographics of the labelers. We did an internal project at Huggingface with a labeling company, and this was actually quite important because if you're asking about like cultural references, like, give me some movie list or something like this, we saw like large variation depending on whether, the annotators were in Australia or in America, which makes sense. I'm not sure of like much more information about that. One thing that is like an interesting kind of question that's been had at Huggingface and with the community is whether you could do something like LMSys, but instead of having this kind of like competitive nature of like, which model is the best in absolute, have a kind of online training situation. So you take the best base model, like maybe Llama 3, and then you just continuously update it based on community preferences. So the idea could be that this way you can really get vast coverage, potentially, across languages, across cultures, and then that would give people potentially the ability to have, you know, like not a Swiss llama, but maybe, you know, something that's a bit more tailored. The challenge we've seen is all these community approaches, they need to be sustained. And there was a thing called Open Assistant, which was actually led by a guy in Zurich. And they did a great job building like one of the first human preference data sets, which was high quality. But then people just have lives. I mean, at some point you get bored of labeling, and you know, so we haven't quite thought about how we can bridge that gap, but it's something that we're thinking about. I'm not sure. I haven't seen any state actors. No.
Thanks for the talk. I have a question. I think it's not, and for example, we want to use AI to summarize very long documents, even, and actually humans are ready to by summary from our preference. And we also check to do it, and we often generate very lengthy summary with solution. How do you suggest? Do you think this summarize by tuning and the island method could be helpful in generating human preferred summary or not? Or do you think
Yeah, so this process of fine-tuning can work. The original work from OpenAI was actually on learning to summarize from human feedback, and they had this exact same challenge. Is like you've got long kind of summaries, sorry, long documents you want to summarize, and then how do you measure the summaries? Fine-tuning plus these methods will probably help improve. I think the big challenge is the long context. So if you put a book, you've probably got, I don't know, several 100,000 tokens. It's gonna be a lot. I'm not sure, like with open models, how well you can fine-tune them to get like reduced hallucinations. But one common thing you see from, say, Gemini, like with this very large context, is it's able to often accurately retrieve individual pieces of context. So possibly it gets solved by the proprietary models. But yeah, it's an empirical problem. Mm-hmm.
Is that kind of way that we do it? It's just like top K? Or is it just like
Yeah, so usually just sampling. So using some fixed temperature is good enough. If the model is small, you have to do these hacks like top K and nucleus sampling because the generations will be very, very strange. But now with many of the sort of, let's say, 7B and above, just pure sampling. The reason to do that is to minimize the amount of parameters to tune. And generally speaking, if you look at the distribution of like your kind of outputs, like so you look at like the token distribution, and then you look at like sort of the overlap of like, okay, which one was more preferred and chosen. You'll see over the process of training, you may have to tweak the temperature, for example, because suppose you're doing, say, math or coding. In the first step, the model might be kind of garbage, so you have to kind of just, you know, make sure you have like good and bad answers. But as it gets better, you need more diversity, so you need to increase the temperature. Yep.
Yes, thank you for the talk. I just have a question. When you talk about using ChatGPT to evaluate synthetic human feedback, what do you think about using other open LLMs?
Yeah. Yeah, great question. So we've done a lot of internal experiments with like Mixtral and Llama 3. Unfortunately, they're not quite good enough yet. So what we've done is looked at like the correlation. So the Alpaca eval benchmark, they actually provide the human annotations that they've developed themselves. And so you can compute the sort of overlap or the correlation between your model's scores versus the human scores. And what you typically see is that, you know, GPT-4 and Claude 3 are like really in a category of their own. And I think it's just because of the capacity of the model. I mean, even a 70B model is going to struggle on certain problems. One thing that has worked quite well is using open LLMs to kind of label data. Like, so there's a kind of trend at the moment of like just generating synthetic pre-training data. You may have heard of the Phi models from Microsoft, and we're working on like replicating part of that process. And what you want to do there is to be able to, first of all, like train a kind of classifier for good or bad data. And you can use Llama 3 to just annotate just web data quite well. This works, surprisingly good. So I think, if Llama 400B is ever released, maybe then we can switch.
Business model.
Mm-hmm.
For them, it's really bad if open source model basically piggyback capabilities and come up with a much cheaper model.
Yep. So I'm not aware of any takedowns on the hub. And this is like the never-ending discussion that people have because the terms of service say you can't train language models to compete with us. I think so far no model is close to their own model, so they're probably not so worried. I don't know. I think it's a weird gray area. Like people say the worst they could do is cancel your subscription. But since the law is evolving, it's hard to say. Personally, I think it would be a pretty bad PR move if they went after open source like this. So I guess unless, there's a GPT-4 equivalent open source. At the back. Mm-hmm. Yep. Yeah, so this is actually in the ultra feedback data set. Let me find it. Here we go. So here they actually had multiple outputs, and they're ranked, but they're ranked across different axes. So they're ranked across does it follow the instructions? Is it factual or not? And so you could define how diverse is this response? And then it's up to you as like the fine-tuning step to decide, okay, which one of those criteria I want to favor more. One common challenge you face is that if you try to put a heavy weight on like what is called, say, harmlessness or safety, so the refusals part of the model, you will then often limit the capability. There's this kind of tax that people talk about. So there's a trade-off of if I want the model to do something very well, it might do worse at other things. Mm-hmm. So great question. I think the biggest challenge is two things. One is the base models are not strong enough, like the open ones, that they're not really very good at math. The other one is that when we do this, let's say, let me find the example. So let's go back to here. Okay, so when we do, say, DPO, you've got this preference data, and in math, it would be potentially two proofs, and then you have to check which one is the correct and incorrect. The problem is there's multiple steps of reasoning, to get there. And the language models, they often hallucinate one step incorrect. So they might get the first three steps right, and then they hallucinate some, incorrect computation, and then the rest of the proof is completely wrong. And most of these methods, they work only on the final step. So if you get the answer right, it's +1. If you don't, it's -1. OpenAI has a very interesting paper, what's called process level supervision, where they break down the theorem proving into individual steps, and each step now gets a reward. We haven't been able to replicate it, and so it's work in progress. But it's something that I'm looking at to see if you can bridge that gap. Yep, that's true. The tokenization is a big impact on things like arithmetic and stuff like that. But I think that for the hard math problems, it's much more a capability question.
Maybe the last question regarding these agents that can use some kind of special domain language
Mhm.
where you have a solution, you know whether it's correct or not, programming or database or playing chess or whatever. Do you think if we expose the models to a lot of these special domain problems where we have clear answers, would it improve general language capabilities of the model, or we just train specialists that basically cannot talk to each other because they're too special in their knowledge?
That's a great question. I think one way of looking at it might be is like, suppose I give a language model access to the web. Can it generate better answers? And I think in that case, we know from these tools like the UIs that it does. So you can improve the quality of the outputs this way. What is a bit unclear is like, at the moment, all these models are not super reliable. And so if I have to build an agent that does multiple steps of, thinking about what to do, which APIs to call, doing this in a reliable fashion, I think hasn't been fully solved. And maybe then the question is, do you have language models communicating with each other? Like, hey, I want to buy a car, and then the LLM from the car vendor is talking to my LLM. That is not an impossible future, but to get there, I think we have to solve some very hard reliability questions. Should we start there?
Thanks a lot, Luis. Also, very interesting talk.
Thank you.
And before we stop, we want to give you a present.
Wow, thank you so much.
Specialists from the region.
Great, thank you so much,
Thanks
Albert.
a lot.